Good evening, everyone. Myself Gautam Sarma. I welcome you all in a Sapiens Education. So today I'm going to solve question number 9.4 from NCERT. It's the chapter is fluid. So in question number 1, they are asking to keep a piece of paper horizontal, you should blow over, not under it. What do you mean by this? See here, as logically we thought that if we will blow air at the top, so what will happen? It will go down. But as it doesn't happens. It doesn't happens. Why this happens? Does not happens. Try to understand. If we blow air at the top, so what will happen? So if we blow the air at the top, so the velocity of the air is v1, and velocity of the air below the paper will, let us consider bv. So we know that above and below. So velocity of the above will be greater than the velocity of the below because we are blowing the air. So if we blow the air, so velocity will be high. So when velocity will be high, so it means that the pressure is low as per Bernoulli's theorem. As per Bernoulli's theorem, okay. So if pressure is low and pressure below is high, so what will happen? It will try to lift the paper. So that is why to keep a piece of paper horizontal, one should blow over it, not under it. Now the second question they are asking, when we try to close a water tap with our finger, fast jets of water gush through the opening between our finger. So what happens? See here. Let us consider this is a pipe. This is the larger pipe. Now water is coming over it with the velocity v1 or v initial. Now when I put here fingers, if we put here fingers, so what will happen? Here if area is a1 and here area is a2, area of opening, area of opening through which water will come out. Okay, if water will come out, so through which the area will water will come out. So from here, when we obstacle it, when we keep a thumb, when we keep a fingers, so what will happen? Actually area will decrease, that is a2 is less than a1. Now as per the equation of continuity, we know that a1 v1 is equal to a2 v2. Now we can see that v2 is equal to a1 v1 by a2. If area is decreasing, so definitely velocity will increase. So due to equation of continuity, we can explain that equation of continuity, we can infer that a1 v1 is equal to a2 v2. Hence velocity v is very high. I hope you have understood this question number b. Now let us discuss question number c of 9.4. Question number c, the size of the needle, the syringe controls the flow of rate better than the thumb pressure exerted by the doctor while administering an injection. Now we can know that if we apply a pressure on the syringe, so what will happen? Let us consider this is a syringe and we are applying, or doctor are applying a pressure delta P, this piston. Now what exactly happen? If there is a flow rate, this is a small needle or needle opening, it has a radius r, it has length L. So the flow rate, that is Q is your flow rate is controlled by this one. So it means that flow Q is dependent on r to the power 4 in and L into delta P. Now see here, when we observe here, so how many factors are controlled by doctor? So only one factor is controlled by the doctor. Factor is controlled by the doctor. But what about this one? So the 4 plus 1, that is 5 factors controlled by needle. Controlled by needle. So if we apply a pressure, so what will happen? The only most of the factors have been controlled by the needle, but only few factors is controlled by the thumb. That's why the from here, from where we can say that the size of the needle of the syringe controls flow rate better than the thumb pressure exerted by a doctor while administering an injection. I hope you have understood this. Okay. Now let us do question number D. A fluid flow out of the small hole in a vessel results in the backward thrust on the vessel. Now let us consider this is the vessel. This is the vessel. Okay. This is the vessel, and this vessel has a one hole and it is full of water. And let us consider there is a two wheel on it. So what will happen if no external force is applied here? No external force is applied. So what will happen? So water is coming out, so it has a momentum P is equal to mb. So if there is a momentum is there, so net momentum should be total momentum should be 0. So there an opposite momentum will be act minus mb on this. This means that the force will be act on this direction. So that's why it will move the vessel, or the thrust will be applied here. So back thrust will be applied. Be applied. Okay. So here it is your Newton's third law of motion. Newton's third law of motion indicates this. Okay. This is Newton's third law of motion. I hope you have understood this question. Now let us do question number E. A spinning cricket ball in the air does not follow the parabolic path. So let us consider it is a ball. Generally, ball, and in ball, what happen? If we make a rough surface here, and another side there is a polished surface, and if we spin it, so what will happen? If we spin it, if normally thrown, if ball is normally ball is thrown, what will happen? Is thrown, so it will follow the projectile trajectory like this. Okay. But the thing is that when spinning happens, when spinning happens, then what actually happens here? When spinning happens, then what will happen? Due to rough surface, there will be a let us consider air is flowing in this direction. Air is flowing in this direction. Okay. And if ball is being rotated like this, so what will happen? If ball will be rotated like this, so the air molecules will get reduced the speed. So here speed will be less. It means that velocity is less, and here velocity is high, and here velocity is low. So due to this, what will happen? As per the Bernoulli's theorem, so pressure will be high, and pressure will be low. So if there will be change in a pressure, so what will happen? Downward force will act. So due to which what happen? If a ball is not spinning, so it will go like this. But when we spin the ball, so ball may come down at this direction. So may not follow the parabolic trajectory due to Magnus effect. Okay, this is known as Magnus effect. So due to Magnus effect, this happens. I hope you have understood this, right? Here there is another question. There is another question 9.5. In question, it is telling a 50 kg girls wearing a high heels. So there is a girl whose weight is 50 kg. Total weight is how much? Or mass is given as 50 kg. Okay, the heel is in circular, uh, circular, circular. His heel is circular. Let us consider. We can make a heel like this. Okay, so this is the shoe and this is the heel, and it has a circular diameter. Diameter is equal to 1.0 centimeter. What is the pressure exerted on the heel? So we know that pressure is equal to force by area. What about the force? See, a girl wearing heel shoes balances on a single heel only. So there is no other heel is there. So only single heel. We will talk about only single wheel. So force is equal to mg divided by area. So mg is how much? M is mass is 50 into 10 divided by area is equal to pi into r square. That is equal to 1 into 10 to the power minus 2 whole square divided by 4. It's the diameter. So finally, it will be 5 4 ja 20, 200 into 10 divided by pi into 10 to the power minus 4. So this will be 2 00 000 into 10 to the power 4 divided by pi. So here, when you do the calculation, so you will get here 6.2 into 10 to the power 6 Pascal. So which is the right answer? I hope you have understood this question. Now let us see question number 9.6, torus barometer used for mercury. Okay, let us understand the question. A torus barometer used mercury and Pascal duplicated it using a French wine of a density 9.8 984 kg per meter cube. Determine the height of the wine column for the normal atmospheric pressure. So let us consider there is a two barometer, and one is made for by Torus lease, and another is there, and it has been made by French and French scientist using a scientist, a Pascal scientist, Pascal duplicated it using French wine. But the thing is that if the level of the liquid is here at this height, let us consider this as a height here h, and if we talk about the level of liquid at this one, so this is also h. But here let us consider this is your h1 and there is h2. If we talk about the density of the liquid, here is rho1, here density of the liquid 2 is rho2. Now one thing we need to understand that how much pressure at this point is there. So I hope we know that pressure at both the place will be same, because it is atmospheric pressure, so pressure will be same. So if pressure will be same, it means that rho1 g into h1 is equal to rho 2 g into h2. Now if we talk about the rho1, so rho1 is the density, so rho1 is 13600 into if GG got cancelled out, so into height is height for the normal atmospheric pressure for the mercury is, we generally know, 0.76. We want to know the height of the French wine, so the density of the French wine is given as 984 into height h2. So from here we can find height h2, so this is equal to 13600 into 0.76 divided by 984. Now when we do this calculation, so I think approximately it will be come under 10.5 meter. So this is the answer. So I hope you have understood this. Thank you. Now see here, question number 9.7. Question 9.7. It is saying that a vertical offshore structure is built with a stand of a maximum stress of 10 to the power 9 Pascal. Is the structure suitable for putting up on the top of an oil well in the oceans? Take the depth of the ocean to be roughly 3 kilometers. Ignore the ocean's current. Now let us consider, this is this is a this is a oil well and this is a stand, okay? And this stand has been put for a 3 kilometer, under 3 kilometer. You know that here there is a atmospheric pressure, right? But here we have a atmospheric pressure plus rho gh, that is pressure due to seawater. Pressure due to seawater. Okay. Now the thing is that the capability of to take the stress for the stand is how much, 10 to the power 9 Pascal. So means that the pressure, actual pressure should be less than 10 to the power 9 Pascal, then only it will be safe to install this. It means that the P atmospheric pressure plus rho gh must be less than or equal to 10 to the power 9 Pascal for safe installation, right? So let us check now what is the P atmospheric pressure plus rho gh. Now here P atmospheric pressure is 1.01 into 10 to the power 5 Pascal, plus rho is the density of the water, that is 10 power cube into let us consider the gravity value as 10 into height. So height is 3 kilometers, so 3 will into 10 power 3 meter. Okay. 3 kilometer means 3 into 10 power 3 meter. So when we add on, so this will be 1.01 into 10 to the power 5 plus 100 into 10 to the power 5. So 10 to the power 5 is common, so this will be 301.01 into 10 to the power 5. Okay. So I think when we take it as a 3 in 3.01 into 10 to the power 7, so which is very less than 10 to the power 9. Hence what should be the conclusion? Conclusion is that a offshore structure is built to withstand a maximum stress of 10 to the power 9 Pascal. Okay. Yes. So I hope you have understood this question. Now let us do next question. Now next question is 9.8. In this question, a hydraulic automobile lifts are designed to lift a car with the maximum mass of 3000 kg. The area of cross section for the piston carrying a load is 425 centimeter square. What is the maximum pressure would the smaller piston have to be here? So maximum pressure as per the Pascal's law, as we know that as per Pascal's law, whatever change in pressure, that is delta P, will occur, it will spread in all direction, spread in all direction for same quantity, for same amount. Okay, now let us see here. If the car is there, so car has a mass, so due to car there will be a change in a pressure definitely. So change in a pressure will be, let us see here, change in a pressure will be force by area, but here force is how much? Force is 3000 into 9.8, because force is equal to mg, and divided by area. So area is 425 into 10 to the power minus 4 meter square. I have converted the centimeter square into meter square. Okay, now when we will calculate this, so we will get approximately 6.92 into 10 to the power 5 Pascal. So maximum pressure is maximum pressure is 6.92 into 10 to the power 5 Pascal. 5 Pascal, the smaller, put the smaller piston has to be a. Okay, I hope you have understood this. Now let us consider question number 9.9. A U tube contains a water and methylated spirit separated by a mercury. The mercury column in the two arms are in level with 10 centimeter of water in one arm and 12.5 centimeter of the spirit in other. What is the specific gravity of the spirit? Now let us draw the U tube first of all. Now in this, let us consider this is a mercury. This is a mercury, right? And on other side there is a methylated spirit. So this spirit is 12.5 centimeter, and this side there is a water, and the height of the water is 10 centimeter. Now one thing we should understand, that the level of the mercury is same, So pressure at this point as well as this point will be same. So let us consider the pressure at A and B. So if you want to find a pressure at A, so pressure at A will be equal to pressure at B. Now pressure at A is equal to P atmospheric pressure plus rho, that is density of the water, into G into height of the liquid column. So that is equal to height of the liquid column, and this is equal to atmospheric pressure plus density of the spirit into G into height of the spirit. Okay, now this can be cancelled, and after that G will also get cancelled. So we want density of the spirit. So density of the spirit will be equal to density of the water into height of the water divided by height of the spirit. So when we put the values here, so what we are going to get, see here, density of the water, that is 10 to the power cube into density of the height of the water is 10 divided by height of the specific gravity is 12.5. So this will be totally equal to 800 kg per meter cube. Okay, now we want a specific gravity of spirit. So this will be equal to density of spirit divided by density of water. So this will be 800 divided by 1000. So finally this is 0.8. So this is specific gravity, Sg for spirit. Okay, so this is what we required. I hope you have understood this. Okay, now let us solve question number 9.10. In 9.10, in the previous problem, if 15 centimeter of water and spirit each are further poured into the respective arm of the tube, so what is the difference in the level of the mercury? Now whatever we have got, see here, whatever this scenario is there, so it will get changed. Let us consider again, I will make the same YouTube. See, let us consider I have made a YouTube here. Okay, so this is the YouTube. Okay, so this is prepared. Okay, I have made this YouTube. Got it? Now in this we have put some mercury. So the thing is that we have put some mercury, right? Now they are telling that what was the earlier case, they have also put some 15 centimeter of the water in this side and 15 centimeter of the spirit, but you know that the specific gravity of the spirit is less than water, so water is more heavier. So what will happen, water will try to create a pressure, and due to which this pressure, what will happen, there is a fall in a, there is in one side there is a fall in a level of the spirit, but on another side there is a rise in the rise in the spirit level. Okay, now see here, at this level we have a same pressure. Now the scenario you should understand. From this we also have a spirit spirit of 12. See here, let us consider this is a spirit, and this spirit is, let us consider 12.5, and there is a water in this. So if there is a water in this direction, and the height of the water earlier case was how much, 10. Now we need to put here 15 centimeter on the both the side. We need to put 15 centimeter more water. So from here 15 centimeter water, and from here also we have put some 15 centimeter of the spirit. So let us consider we have put 15 centimeter of the spirit, right? So this is 15 centimeter of the spirit. Now one thing, it is clear that in earlier case, due to this 10 centimeter and 12 centimeter, we are getting the same amount of the pressure, that is the same level. So for this case, what happen if I will remove this 10 centimeter and 12 centimeter? So finally no effect will be there, because it won't change any level of the mercury. So if we remove this, so the final figure we have figure will be like this. Figure will be like this, because if you remove this, there will be no change in the level of the mercury, because they are creating the same level of the mercury. So we can easily remove this. So let us remove. We have done removal, and let us consider this as a, okay, we want this distance. Okay, now at this distance we have a water of 10 centimeter, and at this also is in this level also we have a spread of not 10 centimeter, it is 15 centimeter. In this direction also 15 centimeter. Now if we consider a point A and point B, let us consider this as a point A and this is as a point B. So the pressure at point A will be equal to pressure at a point B. Now let us put here pressure at A is equal to pressure at B. Now pressure at A is equal to density of the water into gravity into height, that is equal to height of the water column, that is equal to 15. And atmospheric pressure is common, so we can cancel. Now in this direction, now the density of the spirit into gravity G into height is 15 plus this one. So density of the mercury into G into height of the mercury. So this height we need to put. So G got cancelled because all G's are common. Now if we subtract this, so this will be how much? 15 will be common, rho water minus density of the spirit, and this is equal to rho Hg into height of the mercury. So rho water is 1000, so put here 1000 minus 800. Why 800? Just now we have got 800 as a kg per meter cube as a density of the spirit. So this will be multiplied by 15, and this is equal to rho Hg into H, height of the H. Now the height of the mercury column is equal to 15 into 200 divided by density of the mercury, that is 13600. So when we calculate this, so we will be able to get in centimeter, that is equal to 0.220 centimeter, or it is 2.2 mm. So this is the required answer. So there is a rise in the level of the mercury in one side is 2.2 mm. I hope you have understood this question. So we will meet in the next part of the video for solving from 9.11. So thank you for watching my video.